So today we are privileged to have eminent industry expert Mr. 𝐀𝐧𝐚𝐥𝐲𝐭𝐢𝐜 from Intellex Bangalore. Will be delivering a session on AI transformation for education and industry. With his busy schedule, he accepted our invitation to deliver for today's session. With that, now I request Professor Priyanka Madam to introduce our resource person. Over to you, Priyanka Madam.
Thank you so much, sir. It is with great pleasure that I extend a warm welcome to all the distinguished participants who have joined for us today at FDP. In today's rapidly evolving technology landscape, AI is not just an emerging field, it is also a driving force that reshapes industries, economics, and societies. We are also, hold on. Sorry for the interruption. There was some technical issue here. So we are honored to have a diverse group of faculty members, researchers, industry professionals, and scholars from various institutions and domains. We are also privileged to have with us Mr. Vijay Shankar Kanakarajan, an industry leader with over 23 years of experience in software innovation, consulting, and enterprise technology solutions. Their expertise will undoubtedly provide us with valuable perspectives on AI role in shaping the future. With that, I once again welcome each one of you to this enriching learning experience. Let's embark on this journey together with curiosity, enthusiasm, and a commitment to being future-ready in AI and emerging technologies. Wishing you all an insightful and productive FDP ahead. Over to you, sir.
Sure, madam. I thank Priyanka madam and Ashwin sir for a warm introduction. I'm sharing my screen now, and then let us jump into the session right away. Hope all are able to see my screen, right?
Yes, sir. Yes, sir.
Yeah. Thanks for the confirmation. Yes. So yeah, this session is for AI transformation for education and industry. Mostly my experience is in manufacturing industries. Okay. As Priyanka madam told, 23 years. This is my brief profile. Totally 23 years of experience in software industry. Out of this 23 years, I was providing the solutions for manufacturing industries almost for more than 12 years. From like, I think people may know the industry 4.0. The term was coined in one of the very well-known industry fair, Hannover Messe. So every year it happens in Germany. In 2013, this particular term was coined, and after that there were a lot of discussions, and then some standards were also are published. From 2013, I am into this industry 4.0 field, okay, particularly for the manufacturing industries. And also, I wrote a book on the Python, Django, mastering rapid application development and deployment. So I think here most of the people are talking about AI/ML. Do we have to learn full stack development also as part of AI/ML, or at least to some extent? Anybody want to respond? Yeah, so in my industrial experience, yeah, definitely it is required, at least because so whatever solutions we are building with AI/ML, definitely there is a need for creating some kind of an user interface, at least knowledge, at least some extent of experience is needed with the full stack development. any full stack development tool like Django or Flask or something may be needed actually. Yeah, and then you can jump into you can having some deep understanding on this AI/ML kind of stuff. Okay. So next, let's go here actually. So this slide I want to present to all because this gives a clear, complete picture of the analytics, starting from basic statistics models to how we are at now with AI models, the latest very complex AI models. Okay, so the first one is descriptive analytics, and as part of this descriptive analytics, mostly we know understand what happened in the past. Okay, there are many examples we can give. Okay, for example, these sales reports, and then website traffic analysis, and then in the manufacturing industries, if you take there are a lot of KPIs are there. So one of the KPI, let us go in depth during the predictive analytics, or sorry, the descriptive. I have a few more slides for each of these the headings, whatever I had given here. So I'm planning to provide a description, detailed description, and then some examples how it can be used in the education and as well as in the industries. Okay, so descriptive analytics is mostly about what was happened in the past. Okay, and the diagnostic is about some kind of like why it happened. Maybe you'll do some categorization. So all those things will be coming under diagnostic. And next is predictive. As part of predictive, this is one of the hot topic now actually, predictive analytics. One of the main use cases, predictive maintenance. So mostly at present, industries want to implement predictive maintenance in their industries to cut down the cost, maintenance cost, and also it give a lot of advantages. It will help in avoiding production stoppages and all actually. So let us dive into deep on this predictive analytics stuff. It is like with some algorithms like random forest and all, how to predict. Okay, one is the maintenance of the machines. Okay, where we are using most of the time we are using this random forest algorithm to tell a particular machine may fail in another few days. Okay, so that the manufacturers can take some immediate action to avoid the final moment disruptions in production. And also it is a lot of other things are also, like for example, sales also, sales forecasting, we can use predictive analytics. Customer churn, we can use the predictive algorithms. Next is prescriptive. So prescriptive is nothing but after predictive. Next thing comes to is prescriptive. Okay, so like it is kind of a continuation from predictive. So once the prediction is done, then there are some algorithms and getting different information from the global internet. We can prescribe some of the things, like for example here, optimal marketing strategies we can predict based on the customer churn and all actually. And inventory management is another inventory management is one of the important concept in the manufacturing industries, because there is a concept of buffering. So always they want to keep the inventory. It could be the spare parts or their raw material, so anything. So they will have some buffering, and there are a lot of input like the lead time to procure these these inventory items. So based on the lead time and all, they had to order the inventory items actually. So the prescriptive analytics can tell when they had to order, what time they had to order, and also this prescriptive can also tell, like for example, if you take any manufacturing industries, there will be a lot of raw materials they had to procure. Okay, particularly these process industries, if you say there are different types of industries in manufacturing, discrete manufacturing and process manufacturing. The discrete manufacturing, where the assembling, most of the time the assembly happens, we call them as discrete manufacturing. For example, automobile industry is a discrete manufacturing. Process industry are like where the raw materials are processed, like heated or cooled or mixed. When those kind of things are happening, we call those kind of industries as process industries. Okay, like pharma is a good example for the process industry. Paint industry is a process industry. So like for these industries, the raw material they have to source from multiple vendors. Okay, the prescriptive analytics can tell, based on the past history, it can also prescribe like which vendor can deliver a quality raw material at lowest cost. So based on the data, whatever the industries are having in the past, this prescriptive analytics can prescribe, can tell this kind of information as well actually. Next is cognitive. Cognitive is like a human-like thing. So whatever some analytics we are doing with a kind of a human-like approach, if you wanted to do those kind of analytics, comes under cognitive analytics, like sentimental analysis, chatbots, and also the visual inspection, and all those things are also comes under this cognitive actually. Visual inspection is also another major requirements in the industry, automated visual inspection. Okay, that is also one of the important use case in the industry. They want to apply the AI to find the defects in their products actually. Okay, that is also one of the important thing. So those kind of use cases comes under cognitive. And text analytics, like customer feedback analysis, and then social media monitoring, all those things comes under text analytics. Okay, so mostly like descriptive, diagnostic, predictive, prescriptive, cognitive, text. So these analytics, maybe even a couple of years back itself, people were talking a lot about these analytic methodologies. And next one is the generative AI. So yeah, I think last 1 or 2 years, this generative AI is most talkative terms in terms of technology and how it helps the industries actually. So it creates the new content, text, images, etc. It's not only text, images actually, even like in industries as well actually. So we can have some kind of an advanced chatbot where based on the data, for example, production efficiency data, the generative AI can suggest some recommendations. Okay, so in the chatbot itself, for example, the one example what we are implementing now in one of the industries, this one, like this is a process industry. There like the production efficiency. Okay, production efficiency is one of the important thing. Okay, so every 3.5 minutes they have to complete one batch actually. Okay, so the generative AI can tell like why the production. It's not a simple chatbot actually. Like simple chatbot, if you ask, then it will say, okay, what is the production efficiency for the last shift? If you ask, then it will say it is a 90.5% or something like that. But generative AI, what it will do is it will add some more information on top of that actually. Like for example, who's the operator? This operator. So whenever this operator is whenever this operator is working on the shop floor, the plant, the production efficiency is really low, but the other workers, the general production efficiency is really high. It is 95%, for example, and this operator works 94 and 80%. So, so this operator may need some kind of a training. So those kind of the suggestions also the generative AI can provide actually. So apart from this statistically, like what is the current current production efficiency, it can provide a lot more information based on all the available data it has in the industry. Okay, that is about generative AI and AI agents. Yeah, this is the latest topic happening. I mean, the most discussed in these days actually. Okay, so people may hear about this a lot of times. So it is like, and also the effect. What is the end effect of AI agents actually? Like, it may take a lot of time, few next many years to come to this kind of state. This kind of state. What I mean is like this user interface, like applications. At some point of time, when the AI agents become more and more mature, so the applications may not record actually. Okay, why applications may not record? Because AI agents themselves will do all the work. Okay, for example, today we are having a lot of systems, like even we have the enterprise applications, and in the education also we have a lot of LMS system, right? Learning management systems. So mainly why we are using these applications, because we have to, by viewing the user interface, by viewing the data, maybe some graph or some results, will take some actions. Maybe like for example, I may raise the procurement order at some point of time. So I will select the inventory raw material, and then I may give some the quantity, how much I need, and I may select from which vendor I need to purchase this, by when I need this particular component. So currently what we are doing is we are doing it manually with the applications whatever we are having. With AI agents, what we can do is we can completely automate this stuff actually. Okay, so we no need to go to this user interface and then do all these things. So like I told, this generative AI can provide some recommendations, right? Like you can go to this particular vendor for the better quality of the raw material and at low, who can deliver the lowest cost. Okay, so the agent will see this, get this input, and then it itself will order actually. So there is no need of any user interface and all actually. So mostly, yeah, it will take a lot of time to go to this state, but I think these are all the expected things happening in the future. And the next one is the physical AI. Okay, physically, they just maybe just few weeks back, I think they started talking about this. So this is also one of the important concept, like enable machines to perform tasks in physical environments. How to apply AI for the machines to perform tasks in physical environments. Okay, so some of these things like self-driving cars and industrial robots and drones, and also in the industries, like for example in Amazon warehouse management, they are having very latest technologies like this automated guided vehicles, they called as AGVs. The manual effort is not needed there actually. So all the deliverables are automatically taken by these AGVs, and it knows based on the coordinates or the indoor location tracking or outdoor location tracking, these things, these AGVs, automated guided vehicles, or these robots can place wherever these deliverables need to be placed actually. So manual interventions are not needed. So these kind of things are coming under the physical AI. And there are some other AI-related stuff like the real-time analytics, where so based on the real time, maybe some actions we need to take, like for example, like if to avoid some hazardous situation in the industry. So if something goes abnormal, immediately something need to be turned off, and all those things we need to do actually. So that comes under real-time analytics. And we have something called as spatial analytics. Spatial analytics is about the layouts actually. Like for example, for industries, if you take industries, the layouts are really machines to do some operations actually. So this the production efficiency is directly related to the layout of the manufacturing industries, where the raw materials are downloaded, and where the finished products are loaded, and inside the machineries, how the things are moving between one stage to another stage. All these things are really important actually. So some kind of a spatial analytics is needed. So those things comes under spatial analytics. And the behavioral analytics you might have heard many times. And edge analytics is another thing where some actions we need to take very immediately. Okay, so instead of there is another thing, cloud analytics. Okay, like the data will be pushed to the cloud, and then some analytics will be happening in the cloud. So all the providers like Google, Microsoft, Amazon, these people are providing a lot of ready-made AI algorithms, and then after completing the analytics, then something will come back to the place where the action actually to be taken. It will take a lot of time. So to avoid those things, the edge analytics is one of the important thing, where the AI will be taken place. The execution of the AI will be taken place in the very close to the place where the action need to be taken. So that way we can avoid a lot of dangerous situations in the industries, and wherever this kind of immediate reaction is needed, we can go with this edge analytics. And augmented analytics is another thing, like where we have the real world on top of which we are providing some information, like we are having Google Glass and all, right? So using real world, on the real world, we are overlaying some of the information useful for doing some operations. For example, again in the manufacturing industry, the maintenance, they are using augmented analytics. So all these things, like okay, augmented analytics. So all the technologies, whatever we are talking about, still it needs some more time. At least here in India, I had seen actually, like it will take some more time to practically to be implemented at a very large scale actually. So still some of the industries are in a descriptive and diagnostic level only. Okay, so there are a lot of opportunities for AI engineers in the future. Okay, so I'm seeing a lot of opportunities. It's a really good time for all the people who are all learning AI at this point of time. We will have a lot of opportunities. So this is about a high-level view on how the statistics to advanced AI models are progressing. So till this point, anybody has any questions, I will answer. Okay, if no questions, I will go to the next slide. So what I'm going to do is, like, for each of these different analytics or AI models, I have a couple of slides. Okay, let's quickly go through these slides. Okay, first is descriptive analytics. Okay, so it is based on the historical data. Sorry. Okay, understand what was happened in the past. Okay, and why it is needed to provide a clear picture of trends, patterns, and the performance metrics. And what technologies we can use. Okay, the data aggregation. So all the things like basic statistics or whatever we are doing, like the average, mean, median, data visualization, run charts, trend charts, some of the KPI indicators. So all these kind of technology, okay, it's tools or technologies we can use. Actually, those kind of tools are used for the descriptive analytics. And in the exam, here there is a picture on the left hand side. So this is one of the dashboard what we created for one of the industry. So where we are capturing this production efficiency, and if it is 43.9% means it's really bad, and throughput, it is 6 batches per hour. This is not good. And then and also like we are plotting the production efficiency, so production throughput trend as well, actually, like day wise. And then the bottom we have this OEE, overall equipment effectiveness. This KPI, overall equipment effectiveness, is one of the key KPI used in manufacturing industries. So it is a combination of 3 things: availability, performance, and quality. Simply saying, like, if it is availability means like you are planning to use some machine for let's say 8 hours, but because of some breakdown and other issues, you can use only for 6 hours. So that kind of things comes under availability. And performance is like kind of it is in the ideal case, the throughput of that machine could be some, let's say, 100 components per hour, but it is able to produce only 80 components per hour. So that is the performance. And quality is nothing but the rejected, how much percentage are the how much percentage of the produced quantity. The quality is good, actually. So it is a multiplication of all these 3 factors comes into OEE. So these kind of things comes under descriptive analytics. Next is, and we have given some examples here. For example, here, so in the education, so this is how I lay down the slides. So in the education, I had given some examples, and then in the industry, I had given some examples for each of the analytics and AI methodologies, whatever we had seen in the second slide. So here, the student performance analysis is part of descriptive analytics. We just grades, attendance, and all those things we are tracking. So you also may be having in college some kind of a dashboard to have some overall view of each of the branch and then branch students, and then you can drill down further to understand why, where we can improve on all those things. Okay, and this course enrollment trends is another thing where we can use the descriptive analytics and LMS reports, exams and test score trends, dropout rate and retention analysis. These are some of the examples where we can use the descriptive analytics. And here are some of the use cases where the industry people are applying. Actually, I had given already some examples. So like OE and all comes under descriptive analytics, like sales and revenue analysis, track costs, anything about past. Okay, that is the descriptive analytics. Okay, tracks past sales performance. Yeah. And the sales performance and customer purchase patterns, actually, like so maybe what day, maybe Sunday, weekends they may be purchasing something a lot, actually, but weekdays it may be less, actually. So what the retailers can do is like so the buffering is the buffering. As long as you are keeping more and more buffering, it will cost a lot everywhere. In manufacturing industry, if they are producing more than what the market is consuming, it's a cost for them. In the retail stores, what they are storing in their retail shops, if they're storing more than what is consumed by the people coming to that retail shop, it's a cost. Okay, so to avoid these things, this kind of the analytics are needed, actually. And supply chain inventory management, mainly stock levels. As I told, the stock levels is one of the important thing. And supplier performance, who is giving the quality supply, quality raw materials at the lowest cost. And the logistics efficiency. Who is logistics? Usually these companies will have the logistics partners, like which logistic partner is delivering behavior and market trends. So analyzes customer purchase history and preferences to understand the buying patterns. Okay, buying patterns are really needed to produce what the customer needs. And production and operational efficiency, the machines uptime and defect rates, the production speed to improve the efficiency. So all these things are important. Okay. And next one is the employee performance and HR analytics is also another thing happening as part of the descriptive analytics. Evaluates workforce productivity, the turnover, descriptive analytics. So this is the one mostly we are using even right now, actually. So in all the industries, including education and all the industries as well, actually. And diagnostic analysis, like what diagnostic analysis digs, we dig little deeper into the data to understand why something happened, actually. Okay, so it's like we can have this kind of a Pareto chart, where Pareto chart is nothing but a 80-20 principle, where we say that 80% of the failure will happen with 20% of the root causes. So if you address this 20% of the root causes, 80% of the address, 80% of the problem will get solved. So those kind of analysis comes under diagnostic analysis. So there are tools or technologies. What we can use is this drill down analysis, data mining, correlation analysis, root cause analysis. This correlation analysis is also one of the important thing. Like if something like if some delay, let's say it's cause and effect. Okay, so you because of some cause, okay, let us say the quality rejection. Okay, quality rejection because of some one particular issue in the, okay, let's say this one. Okay, the correlation analysis, let us say the rejection rate. Okay, rejection rate percentage. Okay, this may be varying based on some of the process time. Okay, let us say in the process industries, we are doing some heating process. So once in the semi-finished goods stage, actually. So let us say because of the increase in the heating time, sometimes the quality rejection will be very high, actually. So we can do this kind of analysis. This is really important to understand. Like this, the cause and effect analysis we can do with this kind of technologies, diagnostic analytics, and this also at present very everywhere, healthcare or manufacturing or education. This analytics part is very well used, widely used. And these are all some of the examples. Identify at risk students. Okay, like so why a student is at risk of failing, dropping, etc. Do some analysis, and then probably some students may need more support from the teachers, more training sessions from the teachers. So we need to finding the root cause analysis comes under this diagnostic analysis. The cause of exam failures. So maybe because of adding some new syllabus or teaching methodology, there could be more exam failures. Okay, so we need to categorize the problem into multiple factors, whether it is a new syllabus or a teaching method or a student, the base some eligibility criteria, right? So before learning something, they should know something, so that there's a problem. So we need to categorize these things, and then we need to find the exact root cause, and then we try to address this solution. and evaluating teacher effectiveness and understanding dropout patterns. So when so long back in the villages and all, you can see that even the school kids, the dropout rate was very high, right? Then they introduced this the midday meal and all actually. So then the dropout was reduced a lot actually. Okay, so something like that. So we need to find why the dropout is more, and e-learning platform effectiveness we can assess like quiz scores and then the completion rates, the participation level of each student. All those things we can diagnose, and then we can improve on all those things. And next one, in the industry example, the maintenance equipment failure analysis. So identify the root cause of the machine breakdowns. Okay, there could be many reasons. These sensor problems could be there. The operator issue could be there. Operator may not know how to operate the equipment. So the thing is, like, we need to categorize we have these failures, this much failures, and we need to categorize into multiple factors, and then see you can apply this 80-20 principle, Pareto principle to understand which causes the most issues, which causes the most failure. Then we need to address these things. Customer churn analysis. Customers stop using, examines reasons why customers stop using product or service, and then supply chain bottleneck detection because of the inefficiency in logistics. Why there are inefficiencies in logistics? We can again come up with a lot of levels, factors, and then we can categorize, we can understand why there is a real problem. And the workplace safety incident analysis and the product defect analysis. Yeah, so these product defect analysis is another important thing, because the quality is one of the, one is the production efficiency, how efficiently the plants are producing the products, and what is the rejection percentage. So these are all the important things that determines the cost of a product they are producing, or the profit of the product what they are manufacturing. Okay, so this one, the root cause of defective products. Okay, like for example, we had provided one solution to the plastic mold company. Actually, they are producing these PET jars and the water bottles used for multiple purposes. Okay, so like maybe the machine start time, if it is not set up properly, there could be some issues. And if the extruder machine, it's called as blow molding, not extruder. Extruder is different. The blow molding temperature is very high. If not in control, there are a lot of rejections will happen. So they have to find these kind of issues, and they have to address these issues. All these things comes in diagnostic analysis, analytics. So predictive analytics. We had done some of the use cases. Okay, predictive analytics, predictive maintenance, basically predictive maintenance use cases. We created some solutions, or we can say as a proof of concepts in 2013-14 time itself. Okay, but now it's time for the industries to adapt these things actually. Okay, so this took some time because there is a little uncertainty on these things actually, and also so earlier it was really costly. The sensors, why analytics is highly relevant now, why AI is highly relevant now, because currently the sensors cost is going down drastically, and this cloud cost is going down drastically, and the network cost is going down drastically. So now everyone are able to implement these solutions at the lowest cost possible. So so now the industries started looking into the predictive analytics, predictive maintenance kind of use cases, and they started implementing now. Okay. And what is predictive analytics? Predictive analytics uses historical data and statistical models to forecast future outcomes. Okay, so what will happen in the future, it will forecast, and to predict what is likely to, why it is needed to predict what is likely to happen based on past trends and patterns. Okay, some of the technologies like regression, decision trees, neural networks, CNN, RNN, time series analysis, simulation models, all these things are going to help to implement the predictive analytics use cases actually. Okay, what is meant by simulation models? Here, the simulation models is also one of the important concept coming up now. Okay, so for example, let us say a digital twin. Okay, digital twin. There are two types of digital twin are there actually. One is the process twin, and another is the for product twin and process twin. Okay, this process twin. Okay, process twin particularly used in the manufacturing industries, where they can analyze. Like for example, there are some manual processes will be there. I mean, let's say there are some 5 different stages are there in the manufacturing, and in some places the number of people we deploy. In some people we will deploy some 2-3 pick and place robots, for example, and in the exit phase we will place some 2-3 people again actually. Let's say for example. Okay, so now the simulation models, how it is used actually. So you can there are some sophisticated tools available. Like for example, Siemens is having some tool called Technomatics. Okay, like the Dassault system is having some tools for coming up with these kind of simulation models, where if you give these input, like I'm going to place some 3 people at the at stage 1 and 2, and I'm going to keep some 3 robots in the stage 3 and 4, and in stage 5 I'm going to give another 2 people. So in that case, if this is my model, then what will be my production throughput? So it can tell, it can simulate, and then it can tell actually. Okay, so what you can do is, like, based on the production orders, what you can do is you can use this simulation model, and you can tell, okay, so my production order, my demand is 1,000 products I need to produce in a day. Then in that case, what should be my configuration? What should be my number of employees? What should be my number of robots? And how the machine should be organized. So all these things we can use this. We can come up with these simulation models. Okay, so this is really useful, and also it is in some industries it is used, but this is still a really a research topic, because very big companies are using these things, trying to use these simulation models, but the small and medium scale industries are still lagging here. So if we can find some solution for the small and medium scale industries, this is also one of the important opportunity for all the AI engineers to pitch in these kind of industries for opportunities. Yeah, and the predictive analytics. So here some of the education examples: early warning system for student dropouts. So yeah, you are predicting based on some data, saying that these many students will be dropped out, and you can take some action at the earliest to avoid these things actually. So here, for example, they saw the declining performance and attendance, and then what they are doing is, okay, they are giving some intervention programs to avoid this issue, and personalized learning pathways. So based on the market trend and all, it can based on the market trend, and then the student strengths, They can combine all these data, and then they can provide some personalized learning pathways, and predicting exam performance based on the historic academic performance and study habits, and optimizing course enrollment demand, like high or low enrollment, like maybe this enrollment, number of enrollments, those courses, and then career path, the job placement, etc. So all these things we can use predictive analytics. And the industry examples, again this predictive maintenance is one of the important topic which the industries will start applying in their industries now. So potential equipment failures based on different factors like vibration, noise, temperature, and energy consumption. So these machines, let's say if a machine uses the AC drives or DC drives, okay. So this vibration, temperature, noise, energy consumption, and when it was lost, maintained, when is the next service due. So these are all the different input. With this different input, we can predict machine may fail in another few days. The survival percentage is 80% for next 2 months, and 90% for next 3 months. Sorry, not 90%. Survival percentage is maybe 20% for the next in the next 6 months. The survival percentage is 20%, and after 8 months it will die. So those kind of predictions we can make actually. So for that, predictive maintenance is used, and demand forecasting in retail is another use case. Based on the historical sales, market trends, and customer behavior, these are all the input we can use for demand forecasting. And customer churn prediction, to stop using sometimes the customers stop using the product, okay. Even before they stop using the product, we can know, we can see the trend, okay. We can see the trend, and then we can take some actions to avoid reduced sales actually. And fraud detection in finance, this transaction patterns can be used for fraud detection. That is also comes into predictive analytics. And supply chain optimization, this is also one of the important topic or important use case for the industries to take care actually, okay. Like there could be many reasons, okay. So for example, what kind of vehicle they are using, weather conditions. Weather conditions is also important thing. Then with weather conditions, we can tell that okay, so this particular delivery may happen late. So those kind of predictions we can make. So this predictive analytics, predictive maintenance technologies are currently industries want to apply actually. Here there is one example. We built one use case for us for the predictive maintenance, okay. So if you see this black one, this is having some 5 different parameters. One is the machine name, and another is the lost when it was failed, and the next one when is the next maintenance, and next temperature and vibration. These 5 parameters we are having. These 5 parameters are fed into the random forest algorithm. Train, this data set is training data set is given in the random forest algorithm. And then there's real-time data, and then we once this model, we are sure that this model is outputting whatever is the exact. There will be always some error, okay. So we need to just look for the minimalized error, okay, for these predictions. And we are saying that the real-time, we are inputting the real-time data to this random forest algorithm. And then the prediction model will say the survival analysis output. For example, here if you say the 4th April 2025, for example, the survival probability is 100%, and then it gradually reduces. And at one point of time, the failure is survival probability is 0%, or it will fail. for example, the 16th September 2025, it will fail. So this is so what the manufacturer has to do. Manufacturer has to take some risk assessment, and then probably he has to do the maintenance activity by 16th June 2025 or so actually. So these kind of analysis are really useful for the industries. And mostly random forest algorithm is used. I think when the relationships are non-linear and mixed data types, we need to see the algorithm need to see the pattern, right? So the data for the non-linear. So in that case, the data is not linear. Okay. And also it's a mixed data types, like vibration, temperature, different energy levels, energy consumption. So all those things are different levels. Okay. So by seeing all these parameters, it can say like when the machine or equipment will fail. And then there are some alternate algorithms for predictive maintenance. Okay, there's gradient boosting based on some different uses. Okay, so sometimes we may not have enough data set, then you have to use the KNN, and if there are some time series patterns, then you have to go with the HMM. And if it is just binary classification, you need to go for logistics regression. If data set is not too large and the failure patterns are complex, we can go with SVM. Maybe you can start searching more on these things actually, but mostly people are using the random forest algorithm. Okay, so far good. Anybody has any questions so far? Okay. If no, let's go to the next one. Prescriptive analytics. Okay. So what is prescriptive analytics? Prescriptive analytics goes beyond the prediction to recommend specific actions to achieve desired outcomes. Okay. So this one briefly we discussed. What is prescriptive analytics? Why it is needed? To provide actionable insights and optimize decision making. Okay. So this is what we discussed for that raw material procurement use case. Okay. And what technologies can be used? These optimization algorithms, simulation models. Again, we can use simulation models here. Decision analysis, reinforcement learning. So all those things we can use the prescriptive analytics. For example, robotics. In robotics, we can use the reinforcement. We can implement reinforcement algorithm for robotics, right? For example, let us say a pick and place robot. Okay, so it has to pick a component based on different conditions. So we can apply reinforcement learning for the robot to pick the components as expected actually. Okay, so here it can say this reinforcement learning can say like it will prescribe like what it has to take. Okay, what the robot has to take. So this kind of, and here are some examples for the prescriptive analytics. Okay. So education examples. Okay, personalized learning recommendations. So wherever this recommendation comes, that comes under this prescriptive analytics. Okay. Suggest tailored study plans based on student performance and learning style. Yeah. So maybe like a student may like something and he may not be interested in everything. So some tailored study plans the prescriptive analytics can provide for the student. So this comes under prescriptive analytics. And then students, the retention strategies. So here interventions for at-risk students to prevent dropouts. So some like student, it's kind of a counseling, student retention strategies. Maybe this prescriptive model can prescribe some kind of a counseling methodologies as well. Okay, so that we can use those counseling methodologies. It's based on, everything is based on data, right? So So these things mostly they will be correct. I cannot say 100%, but we can use. So whenever this prescriptive analytics, there will be some error. All the analytics models, there will be some error, and more data, it will reduce the error. Okay, when we are so the prescriptive analytics can provide some recommendations on counseling and optimized course scheduling based on the demand, faculty available, and resource constraints. It can the prescriptive model can provide some kind of a course scheduling and adaptive testing and assessments. Okay, dynamically adjust test questions based on student response to improve learning outcomes. Next one is the resource allocation and budget planning. So here, like where to allocate budget, that is also if based on multiple factors, if a prescriptive analytics engine, if it can tell exactly, it can tell the trend, what is the current trend in the industry, and what the students learn. If the student learn which technology, he can get more opportunity. So it can, many data we can fit in. If the prescriptive analytics can tell what courses we can plan, or like for example research R&D, what budget we can plan, how much budget we can plan for particular R&D, which yield a lot of return on investment will be very high. So the prescriptive analytics can provide those kind of the information. And next is industry examples. Again, prescriptive. So prescriptive mostly it follows it predictive. Okay, so this is optimized supply chain management, recommends best routes, suppliers, and inventory levels to reduce costs and delays. Okay, so here, weather data is one of the important factor for the optimized logistics route, and then where there could be multimodal transportation is also possible. Okay, what is multimodal transportation? Like truck, ship, flight. So if something comes to India, then there are multimodal transportation in different routes, it is possible. So all those things, the prescriptive analytics, if you provide a good amount of data, it should be able to tell the optimized logistics route or the overall supply chain management. Then dynamic pricing strategy, this is also one of the important thing. Based on the demand, the competition, market conditions, we can provide dynamic pricing strategies. I think this one is already very widely used in the e-commerce portals. You might have seen the price varies based on multiple conditions. Okay, and also if you see the different airline tickets is another example, best example for having the dynamic pricing strategies. And the automated healthcare treatment plans. So again, the treatment part actually based on the health condition. Fraud prevention and risk mitigation, provide real-time recommendations to prevent fraudulent activities. The workforce optimization and scheduling. So these are all the so what is, like again, these kind of we were talking about these simulation models, right? So it can prescribe, simulation models can prescribe how many employees are needed to meet the production. So how many robots are needed, it can prescribe. So those kind of things comes under the prescriptive analytics. Next is cognitive analytics. Cognitive analytics mimics a human thought process. Okay, wherever so if we applying like a human way of doing some analysis, then this cognitive analysis approach comes, analytics will come into picture actually. For example, this image analytics is one thing what we can say. Okay, for example, I think if everyone can see the camera, if this is the pen, so there could be multiple quality issues. Okay, so if human is testing, human is manually doing the visual inspection, you can immediately understand where the issue is actually. For example, there could be some cracks in the tip of near to the tip of this pen, and some cracks in the in the button where we are pressing the pen. Okay, and some near to this hook. Okay, so human beings, when they see this object, they can immediately see, okay, there is a crack actually. Let's say if we are automating this particular process, then what we have to do, we have to definitely use some kind of an image processing algorithm to do this. It may need a lot of data, maybe let's say some 4,000 data. Out of this 4,000 data, maybe some 500 data, maybe the bad quality scenarios. So we need to embed this knowledge into this our cognitive analytics engine. Okay, so for that we can use some technologies like natural language processing, machine learning, knowledge graphs. Okay, this one, it looks simple, but it is little complex process actually. So it needs a lot of data as well. For example, one example I can tell actually, this is the visual inspection analytics is one of the greater demand in industries actually. So there is one solution I had seen where they are manufacturing some of the metal components. Okay, they want to see any cracks or any deformations in the metal surface. Okay, so this particular component will pass through a dark compartment, so that because when the brightness will impact the output, right? So it is passed through the dark compartment. The dark compartment, they will have this kind of an infrared rays actually. So the infrared rays can easily detect very even minute cracks and all on the surface. And they mounted some 5 different cameras based on the number of cameras, and then the complexity of this path, this dark path. Okay, the price will vary. Okay, so they were doing complex algorithms to find these kind of issues. So those kind of implementing the image analytics algorithm, whatever we discussed, those kind of things comes under cognitive analytics. So education, again, AI powered virtual tutors like meta platform kind of thing comes under the cognitive analytics. The Watson based AI tutors, so all those things comes under cognitive analytics. Then automated essay grading and feedback, something we need to read, right? We are reading the grammar, and like human beings, the algorithm has to think, and then maybe it has to provide some feedback. And then content curation is another thing. The study materials content curation is another use case we can implement with cognitive analytics. And emotion and engagement detection uses facial recognition and sentimental analysis to assess student engagement. This is another use case where we can analyze the student whether they are actively engaging in the class activities or not. So for that cognitive analytics we can use actually. So I think in the older days it is not possible, but now these things can be automated, and it can tell like which student is not engaging actively in your classes, and then we can take some corrective actions so that it is beneficial for the student and as well as for all. And AI based career guidance, again based on the student interest, skills, academic performance. It is also kind of a prescriptive. Some of these things can overlap as well, but But these are all the different analytics methodologies used in AI. Okay. And next is the industry examples. Cognitive customer support chatbots. Chatbots are widely used in industries these days, banking industry, mainly banking industry, and then maybe like, for example, even in the manufacturing industries also they are used actually. Like a customer can inquire about the products and all actually. It's NLP based to understand the customer queries and provide human-like responses. And fraud detection in banking and finance, healthcare diagnosis and the treatment recommendations. The process patient data and medical history to provide the exact diagnosis. It's like how doctor sees or views the reports, let's say ultrasonic scan or ECG, how the doctor view and then how he analyzes. Okay, like a human. Okay, so these technologies can be used in the healthcare diagnosis. The cognitive analytics can be used for healthcare diagnostics, and predictive maintenance in manufacturing. Again, analyze the sensor data and predict equipment failures before they happen actually. So currently, what methodology in most of the industries they are using for predictive maintenance is they call it as autonomous maintenance. So every day or every shift, someone will go to these industries and then see visually how's the vibration. Is there any vibration in the machine? And then is there any heat produced, generated in the machine? All those things they will see visually, manually, and then they will report it actually. If based on their experience, if they are seeing more vibration, then they can tell that, oh, this particular screw or something need to be replaced to do these things actually. So those kind of activities we can automate with cognitive analytics. And AI-based recruitment and talent acquisition, this is one of the very well-known use case currently. All the industries are using. The scans resumes, analyzes candidate profiles, and matches the best talent for the job roles. This is about cognitive analytics. And okay, so this is one example I had given. So this one we implemented. Okay, not in the picture actually. For the quality inspection, we had implemented one use case. Okay, so mainly we used the technologies whatever given here actually. Okay, so as I initially told, whether we need the full stack development knowledge or not for the AI engineers, I recommend at least some level of knowledge is needed. Okay, how the full stack development platforms are working actually. Okay, for example, here we are using Django. Without Django, we will not be able to do this actually for the UI and all. Like, yeah, I mean, sometimes these tools are providing the Python-based tools are providing the direct graphs from the graphs we can learn. But still, if you want to add some more functionalities, like to what is the okay, even without seeing that graph. If you want to display some text content here, it is a problem. Here, some kind of a human way of telling something. Definitely, we need some kind of full stack development knowledge. So here, Django, a Python-based platform we are using, and PyTorch we are using for deep learning framework implementation, and CNN we are using, OpenCV for visual inspection we are using. For image analytics mainly, the SQLite as a database we are using. Okay, so here if you see this picture, anyone can tell me what this person is doing? What this person is doing? Okay, so he is inspecting a pipe, a steel pipe, which is already inside a concrete wall. Okay, so how he is inspecting? I hope this picture all are able to see, right? I hope all are able to see this one, right? So here, for example, okay, here there is one thread is there, right? So this is called as industrial endoscope. Okay, so we have this medical endoscope, right? So this is called as the industrial endoscope. So what he is doing is he's inserting this industrial endoscope to this tube. This industrial endoscope can go up to 15 meters, 20 meters and all actually. And he can see what is happening or what is there inside. Is there any damage in the tube, any cracks in the tube, in the device, whatever he is having, okay? And here also he is doing it little manually. So with this kind of the visual inspection with the cognitive technologies, the cognitive analytics, we should be able to even automate this kind of stuff actually. So this kind of use cases comes under the visual inspection. Next is text analytics. Text analytics involves analyzing the unstructured text data to extract meaningful insights. Okay, so mainly from the social networking platforms, the sentimental analysis, and then the customer feedback in the e-commerce websites, for example, and the customer feedback in the manufacturer websites, for example. So and then people can know like how is my product is going, how my product is liked by the end customers. So to come up with those kind of the information, text analytics is used. Not only there, actually, even text analytics is used one more use case where I think already some of the companies like Cisco and all, I think they implemented some solutions like in the meetings and all, like people are talking multiple things, right? So what it does is like it will capture all the text. It will capture all the text, voice to text. Okay, it will capture all the text content, whatever is spoken, and then it will stratify, or like it will tell like so which is the most used word and which is the next most used word. So those kind of things it can tell, and based on that we can understand what topic is discussed more. So those kind of analysis comes under text analytics. So NLP, sentiment analysis, topic modeling, all these things are all these technologies are used for text analytics. And text analytics, education examples, yeah. So automated essay grading. Again, it's grammar based actually, like what is written. Okay, here what cognitive and text analytics, the difference, there is a difference actually. Text analytics is purely about text. Okay, the cognitive analytics could be multiple, can get the input from multiple sources. It could be image, it could be text, it could be video, it could be sound, it could be anything. Okay, so how, like all our senses, right? 5 senses. So it's like that actually. So whatever it could be, it analyze the data and then give the output. Text analytics, this automated essay grading, yeah, for the text and sentimental analysis and student feedback, plagiarism detection, the academic papers to identify copied content and all, and chatbots for student support, and academic research analysis also it can be used. For example, if a new patent is for submitting patent idea, then the text analytics can be used whether this particular content is already published or not. The industry, if you see again, this customer sentimental analysis already I told, and document processing is one of the, okay, automated document processing is one of the important thing in manufacturing industries. They're generating lot of documents, contract documents. So like and also it varies between industry to industry. Okay, let's say if it is a nuclear power plant. Okay, nuclear power plant, the document management system itself is very complex. Okay, and this automated document processing will help in accelerating the approval processes and all actually. And yeah, so this is one of the major use case people look for from the text analytics perspective. And chatbots and virtual assistants, again, it is uses NLP to understand and respond to customer queries in real time. Chatbots using generative AI also we can implement chatbots. Okay, that that is little different actually than this text analytics. I will tell you what it is actually. Okay, and fraud detection in finance. This scans financial transactions. Again, it is text analytics. It will scan the transaction details and then say whether it's suspicious or not. And then healthcare text analysis, medical records, research papers, doctor notes, and extract key insights. So these are all. This is another use case where text analytics is used widely. Next is generative AI. Okay. So what is generative AI? Generative AI refers to AI system that can create new content, text, images, music, code based on patterns learned from the existing data. Then why it is needed? To automate creative process and generate novel outputs. Different technologies are used like LLMs, GPT, BORD, Llama, GANs, VAEs. I think these kind of things, these technologies in depth, you might have learned in the last 4 days. Right? Yeah, I attended some sessions, a few sessions. They are very interesting, and people were talking in depth. In depth implementation, or how they are implemented, they were talking in depth actually. So these technologies are used for generative AI. We built one use case in our platform. Okay. So it is a chatbot, but it is little advanced version of chatbot. Okay. So it will like this one I already touched upon. So it will see the complete production data, production metrics, the efficiency, raw material consumption, and everything. And then it will see the past history of the operators. And it will tell it. It is not only just if I'm simply asking which batch had the highest production efficiency. For example, it will not only say the batch which is having highest production efficiency. It will also tell like who is the operator, what was the normal production efficiency. It will provide a lot more information actually. And then like that, you can start asking questions, and then it will add more details to the manufacturer or plant heads. So for this one, we used what we used. Yeah. So we use these technologies. Again, we use Django, Pandas, OpenPyXL, Longchain, and these are all the packages, Python packages we used. Other Python packages we used. Google GenAI. We used Google GenAI credentials for this use case. Yeah, but here, so one thing I'm seeing is these responses are very slow. So currently we are planning to optimize the speed actually. Okay, so currently it is taking a minute or so to respond. So when we implement such kind of solutions, we should take care of the speed as well. Because people will not wait for a long time to see the responses. And here, generative AI in education examples, the personalized learning, essay writing, feedback, something writing, okay, something it is creating. With the virtual tutors, AI-driven tutoring, and explanations on various subjects, text-to-speech and AI-powered lectures, and AI-generated educational simulations and virtual labs. Yeah. So, okay, it is generative AI, and there is one more topic actually. There is, virtual reality, augmented reality. Those are also comes under AI for learning purposes, actually, educational purposes. It's academic learning and as well as industrial learning. Okay. So particularly this virtual reality is used because people cannot go to the far distances to see something and then learn. Okay, for example, if there are some oil fields are there, it is quite expensive for the company who hired these people to take all of them to the field and then give them the training actually. So this virtual reality is used for teaching those people what are all the different equipments they used, and how we can maintain those equipments. All those things we can do it with virtual a reality actually. And the next one, AI in industry examples. Product design and prototyping also they are using generative AI. So based on product design is nothing but like, for example, if people are manufacturing aircraft components, okay, it's aircraft components. So the AI can provide the design, okay. For example, there could be a lot of levers, nuts, bolts, many mechanical components are used in the aircrafts, right? So the generative AI can see all the data in the past 100 years, and then it can suggest something which is highly very safe to use those components, so that there won't be any accidents happen in the aircraft. Yeah. So again, these things are still evolving. So, and currently, I think we are in the peak of research phase, and it will move to industrialized phase. Actually, that's what I'm expecting in the coming years. And AI generated marketing content, AI powered code generation and software development. Yeah, this one most of us might have used. And synthetic data generation for AI training, AI generated visual and video content for branding. Yeah, branding can create a visual content. Yeah, this one we know that, right? I mean, sales presentations we can create with the generative AI. A lot of tools are available. And AI agents, I told this is one of the important concept. I already briefly explained. Yeah, so most slowly these things will replace the maybe not completely, at least to some level, it will replace the user interface applications and all when these technologies will become mature. I also told one scenario as well, like this, for example, this production order, raising the production order manually may be completely automated with AI agents based on different conditions in the manufacturing industries. And technologies, reinforcement learning, NLP, computer vision, and robotics. These are all the different technologies used. Then what else? And AI education, AI agents for education examples. Again, virtual tutors. Assume that AI agents doesn't need any application or UI, so it will do most of the things by itself. And intelligent chatbots, yeah, again, still needs some user interface, but it will provide. It's like our agent, okay. Like, so when you ask something, it will give some answers. Automated grading assistance, AI-powered career guidance systems, smart classroom assistants. So all these things to smart classroom assistants, agents monitor students' engagement, suggest teaching strategies for better outcomes. These are some examples of use cases in the education for AI agents. Industry, again, customer support chatbots, virtual assistants, financial advisory, AI in manufacturing, predictive maintenance, AI-powered HR and recruitment agents. Okay. So these are all some of the industrial examples. And physical AI. Okay. So physical AI refers to AI systems integrated into physical devices. AI systems integrated into physical devices or robots that interact with the real world. Okay. To enable machines to perform tasks in physical environments, why it is needed? The machines. This is mainly for the machines. The machines could be robotics. Sorry, machines could be robotics or automated guided vehicles. It could be trucks. It could be drones. It could be anything. Okay, these machines. And mainly technology, these are all the technologies used: robotics, computer vision, sensor fusion, and edge computing. Edge computing also we touched upon briefly. And education examples, if you see like AI-powered robot teachers, assisted lab experiment, AI-assisted lab experiments. Okay, let us say the student is learning something related to nuclear energy. Okay, it's very dangerous. Okay, currently it's taken care with the kind of apparatus what they are wearing and all actually, but still it can be more efficient with the kind of robotics with physical AI. Then smart classrooms, like motion tracking and speech recognition for interactive learning, special education. This is only for the special need children, okay, who need to learn and communicate. Some children may have some special needs. So for those kids, we can use these AI robots. Maybe it could be many things like hearing issues or moving motion issues and all those things. And AI in augmented and virtual reality. Yeah, so the educational, yeah, so the virtual reality is one of the important tool. Even currently also it is mostly used, and going forward also it will be used for in the educational purposes. I think currently building these kind of applications, particularly these AR VR applications, are very little costly. The tools and all little expensive. So once this cost little bit comes down, all these things will be widely used in multiple places. And industry examples, again, these autonomous vehicles, robots in healthcare and surgery, smart warehouses already I talked about, and agricultural robotics, and industrial automation and manufacturing, smart robots and quality control. All those things we can use the physical AI. Yeah. So in this year, AI agents and physical AI, these two things will be most talkative terms. A lot of people will do some research on these things, and then we can expect to see a lot of new things coming in this area. And the AI models comparison, yeah, these are all some of the AI model comparison. DeepSeek, ChatGPT, why they used, and from cost wise there is some differences are there. And there are three critical components to implement AI: data, algorithm, and compute. So data is nothing but it's a material. It's a really core thing to do anything. Without data, nothing can be done. So algorithm, a set of mathematical rules, and the compute. Compute is nothing but the processing power. Okay, so these three things are needed. And some Gartner tech trends in 2025. Again, agentic AI is nothing but AI agents, AI governance platforms to govern the AI systems. Probably some technology solutions may be needed actually. So those kind of things will be the top tech trend in the 2025 as per Gartner. There are some numbers also they had given, but mostly like we can say this kind of things will happen. Okay, and the disinformation security is like how systematically we can increase the trust on AI. Okay, so some tools, some processes, all those things will come into effect. So these are all the, with respect to AI, these are all the different three things Gartner predicts as a top trend in 2025. And yeah, this one I think we are top of the hour actually, so I will not go through this in detail. So this is like manufacturing to understand. Okay, so this one is about us as well. So this is where we are doing our consulting, and we have our solutions. So manufacturing, like from engineering design to production to sales and after sales support, all the phases we are covering as part of consulting, and as well as we are having solutions. And this is a kind of a technology landscape. So if someone wants to look into these manufacturing solutions, they should understand this part actually. Like there are 4 layers actually: machines and sensors, control systems, more manufacturing operations management, and enterprise applications. These are all things they need to know. And we have a platform, it's Python-based platform. I just skip these things. Okay. That's all I have. Thanks to all. If anyone has any questions, please ask me. I'm fine.
Your session was wonderful and informative for the participants. You are talking about AI transformation for education and industry. Overall, the session was highly informative, sir. Thank you so much for spending your valuable time with us. Dear participants, now it's a time to interact with our resource person. If you have any queries, please post your queries in the chat window.
Sure. Thank you.
Yes, participants, do you have any queries? Please post your queries in the chat window.
Yeah, if you need anything, you can contact me at info@intellx.com. Maybe I will type it here. If you need any further details, you can contact through this mail ID as well. Okay.
Thank you, sir. If the participants, if you don't have any queries, now I request Ms. Priyanka Madam to conclude this session. Over to you, Madam.
Thank you, sir. It is with immense gratitude that I take this opportunity to express a heartfelt appreciation to our esteemed resource person, Mr. 𝐿𝐵𝐺𝐴𝐻, for delivering such an insightful and thought-provoking session on emerging AI and technologies. Sir, your vast experience of over 23 years in the software industry, coupled with your deep expertise in cloud and computing, Industry 4.0, and enterprise technology solutions, has truly provided us with a comprehensive and practical understanding of the evolving AI landscape. Your ability to blend technical knowledge with real-world industry applications has made today's session both engaging and enlightening. The insights you shared on AI-driven automation, digital transformation, and its impact on the various sectors like manufacturing and healthcare have not only expanded our knowledge, but also challenged us to think critically about how we as educators and professionals can adapt and contribute to this revolution. Your experience in working with Fortune 500 companies leading innovative technology solutions and mentoring teams across global organizations is truly inspiring. The practical examples and case studies you presented have given us valuable takeaways and we can apply in our respective domains. On behalf of AMC Institution, we sincerely thank you for your time, effort, and willingness to share your expertise with us. Your session has certainly enriched our understanding, and we look forward for future opportunities to learn from you again. Once again, thank you, Mr. 𝐵𝐺𝐴𝐻, for your valuable contribution to this FDP program. Thank you, sir.
No problem. Thank you. Thanks.
Yeah, dear participants, as we conclude the day 5 of this faculty development program with future-ready AI emerging technologies with their societal transformation, I extend my heartfelt gratitude to everyone who made today a success. A sincere thank you to our esteemed resource persons, Dr. Pankaj Kumar and Mr. Vijay Shankar Kanakarajan, for their invaluable insights and expertise. Your sessions have truly enriched our understanding of AI and emerging technologies. Most importantly, a big thank you to all the participants for your active engagement and enthusiasm. Kindly note, dear participants, tomorrow there would be 3 sessions starting from 2 p.m. and it will be ending by 8 o'clock. So after the sessions, the online test and feedback would be conducted, which needs to be attended from the Atal portal itself. So finally, validatory session would be held from 7:30 to 8 p.m. tomorrow. So let's take forward the knowledge gained today and continue to explore, innovate, and contribute to the ever-evolving field of AI. Once again, thank you all for making a day 5 a resounding success. Wishing you a wonderful evening ahead. See you all tomorrow at 2 p.m. afternoon. Take care. Good night. Yes, Hina ma'am, you have raised your hand. Feedback link is already posted in the comment as well as on WhatsApp group, both the places.